about specific type of functions. Chapter 2 talks about a family of functions, but actually two families of functions. One is called the polynomial functions and the polynomial functions. The other one, rational functions. So, polynomial functions are very interesting functions. They are very simple and very easy to work with, and they can be used for modeling in many situations in real world setting. Okay, so, but one type of actually we have seen two types of polynomial before, so let me remind you what we had before. As you remember, we had a constant function, f of x equal to c. This is actually a polynomial. Okay, we actually gonna call it polynomial degree 3. We're gonna get to this on section 2.2, so I don't want to be ahead of myself. Just want to let you know that we've seen some simpler polynomials before. So f of x equal to c was a constant function in one kind of polynomial. Another kind of polynomial that we see, we didn't really do very much with it, maybe a couple examples we did, was linear functions. Linear functions, we wrote them as ax plus b. Okay. So this is the simplest type of polynomial. This is the next simplest type of polynomial. See, this is actually, I can write this one as cx to power 0. See, so because x to power 0 is always 1 for convenience, to avoid contradiction. And this one is ax to power 1. You see, it has power 1. So the next level of polynomial functions is what we're going to study in section 2.1, which are called quadratic functions. And that's it. This is the topic of section 2.1. Okay, so that's what we're going to do. Then in section 2.2, we're going to go back to polynomial and discuss polynomials in more general setting, and then we're going to mention these as simpler examples of polynomials. So, but for right now, we're going to just concentrate on quadratic functions, because quadratic functions are very widely used and has very nice properties. So we're going to study these type of functions specifically on section 2.1. Okay, so that's where we are. So the polynomial and rational functions in chapter 2. Okay, here it is, section 2.1, quadratic functions. Now here's a definition of a quadratic function. A quadratic function is a function whose equation can be written as this form. See, f of x equal to some number a, any real number from minus infinity to infinity, times your variable x to power 2, plus another number b times x to power 1 actually, and then c. And this a should not be 0, because if a were 0, then this term wouldn't be there. Then your function would become a linear function. Okay? So b and c could be 0. You see, b and I said a not 0, but b and c could be 0. Okay, so we're gonna see some examples down here actually. So this is this form is called the general form of a quadratic function. Okay, so ax squared question is, which one of these functions are quadratic functions? Okay, so let's look at each one at a time. This one is, every time you have, if the highest power is 2, then it's quadratic. This is quadratic, you see, x squared. Actually, in this case, your a is 1, b is 0, and c is 0. You see, if I put b and c 0, and a1, then I get this one. And as you remember, on section 1.3, this function was one of those functions in the library of functions. We call it squaring function, as you recall. Squaring function. So squaring function actually is a very simple case of quadratic function. G of x is also, so I'll put check mark, that means this is quadratic. This one is quadratic as well. Then a is 7. Get it up. This one here. A is 7. B is negative 11, and C is 0. This one is quadratic. A is 4. See, there is no x to power 1. That means your B is 0. And C is negative 2.8. But this is not quadratic, see? Because this is the example of what we're going to discuss later on. Remember this here, I said chapter 2 talks about polynomials and rational functions. This is actually an example of a rational function. Okay, so this is not a quadratic function because you have some x in the denominator. In quadratic function, there is, if there is a denominator, there wouldn't be any x in it. So this is not quadratic. This one is quadratic, so check mark. Use a different color here. I think this is blue. A is 2/5. B is negative 3.7, and C is 1/3. Okay. This one is not quadratic. This one is not quadratic. Not. Because you have power 3. In quadratic, you don't have power 3. The maximum power is 3. This is a polynomial, actually, as we see later on, but this polynomial is not a quadratic function. So I would kind of yellow this one here. You see, this is a problem. X to power 3 cannot be there for a quadratic function. This one is not quadratic either. See, you have a square root. Every time you have a square root with x under it, then it won't be quadratic. See that you don't have any radical sign with x underneath the radical sign. So this is not a quadratic function. Not quadratic. This one is not quadratic either. The reason for it, have a negative exponent. Negative exponent. You see right here, we yellow it here, you see. Because in a quadratic function you don't have negative exponent. This one actually is, but it may not look like a quadratic function. So before we say whether it is or it's not, FOIL it or expand it or distribute and simplify to see what you get. So I'm going to go ahead and do this. X times 2x will give you 2x to power 2. X times -1 will give you negative x. Then 2 times x gives you 4x, and 2 times -1 gives you -2. So if I go ahead and simplify this, I get 2x to power 2. Then you have 4x here and -x there. This gives you plus 3x, and then minus 2. And clearly it is a quadratic function. Yes, quadratic. Your a is 2, b is 3, and c is negative 2. Clean it up a little bit. This didn't work very well. This one is also quadratic. Okay. Actually, this is a quadratic function which is in standard form. We're going to talk about standard form on the next few pages. Okay, so I will explain that later. But this quadratic, if you want to really want to see it, because it doesn't readily looks like this, you have to expand it. So I'm going to go ahead and work it out. 3. X to x minus 5 to power 2 means x minus 5 times x minus 5 twice plus 1. Okay. And if you go ahead and expand this just like you did here, see x times x, x times 5, 5 times x, 5 times 5. Let's see what we get. X times x, you get x squared. X times 5, you get negative 5x. Negative 5 times x, you get another negative 5x. And negative 5 times negative 5, you get 25. And then plus 1. And if you simplify this, you get x squared. 5x here, another negative 5x, you get negative 10x. Then 25 plus 1, you get 26. So that makes this a quadratic. Check mark. So your a is 1, b is negative 10, and c is 26. Okay? Okay. Now we're going to look at the properties of functions. So of quadratic functions. So I'm going to write it right here so I can see it. First of all, the domain of a quadratic function means the set of all legitimate x values is a set of all real numbers. In other words, any x value can be used for the domain. Okay, so the domain is from minus infinity to infinity. Then, as we discussed, the parabola is the graph is a parabola. It's either going to open up or open down. So how do I determine whether it opens up or down? We look at the coefficient of x squared. This a here, you see, this a. This is a number. It's either positive or negative. It's not zero. Okay. So if it's positive, that tells you the graph is going to open up like this, you see, this way, this way, or this way. And if a is negative, then it's going to open down. Okay, very simple. So we just look at a and we tell whether it's positive or negative, then we say whether it's open up or down. Then, as we mentioned, the vertex is a very special point, so we always want to know its coordinate. So for one thing, from now on, for the rest of this course, we're going to use the letters H and K for the coordinates of the vertex. So H means the x value. So this is H here, you see, and this is Y. Like for this particular picture, H is 1, 2, 3 and y is 2. Okay. Or if the parabola opens down, this is hk. Like in this case, h is negative 3 and negative 1. Okay. Then if you want to find hk, actually we want to know what it is. The value of h and k depends on a, b, c. And these are the two formulas we use to actually find h and k. Okay. All you have to do is to write down what your a, b, c are and put them in this formula, and then use a very simple arithmetic to simplify to get h and k. Okay. Very easy to find. Then the next thing we're gonna know, we need to know is the axis of symmetry, equation for axis of symmetry. Axis of symmetry in this case is a vertical, okay, because the parabola is vertical, and it passes through the origin. Therefore, its equation is x equal to h. That means any value, any point on this axis of symmetry has the same x value of h. Like in this case, my h is 3, so x equal to 3 for this particular picture. Okay. Or for this one, x is negative 3. See? The range of the function. What is the range of the function? The range of the function is set of all the y values. Well, it depends on the vertex, because if it opens up, doesn't matter which one of these pictures I choose. Let's choose this one. If it opens up like that, that means numbers below the vertex are not acceptable. It's like these values on the green line are not acceptable. I mean, they won't be attained. So no matter what you choose for x, you get something for y in this red area, because parabola is always going up like that. So in this case, the range is from k to infinity, because this is the at this point is k, this point is h. Okay. So the range is k to infinity if the parabola opens up, and if it opens down like that, then numbers above the vertex are not attained. So it would be from minus infinity to k. So this would be the range. Okay. So as you can see, you can, by finding the vertex, you can answer several questions here. You can answer whether it opens up or down, and then by finding the vertex, you can find the axis of symmetry. You can find the range. Domain is of course always minus infinity to infinity. Then the y-intercept. What is the y-intercept of the function? The y-intercept of the function is the point where the graph crosses a y-axis. Of course, in these pictures, my pictures are not big enough to show that. Something like this. If you have a parabola like that, this is the y-intercept. Or if you have a parabola like that, this is the y-intercept. See? So as you know, y-intercept x value is 0, and we discussed this before, that to find the y-intercept, you always put x equal to 0. So f of 0 is the y-intercept. If I put it in the equation, this equation, replace all these x's by 0, I get c. So y-intercept is f of c equal to 0. Okay. Now the next item, the 8th, number 8, is talking about zeros of quadratic functions. As we discussed before, the zeros of a function in general is the x value for which the y value is 0. For example, if I have something like y equal to f of x, whatever it is, and point 5, 0 is on the graph, like f of 5 is 0. You see, if I have this, then phi is called means it doesn't mean that itself is 0, 5 is 0. No, the y value corresponding to that x value is 0. Okay, so that's the terminology. So if you want to find, therefore you want to find the zeros of any function, in particular case here, zeros of a quadratic function, just put the whole function equal to 0. So I put all of this equal to 0 and I solve for x. Okay. Of course, because of this power 2, this quadratic function can have at most 2 zeros. Okay. These 2 zeros, they may be either real or complex. Okay. So for any function, when you find zeros, the zeros could be either real or complex. So let's see what next. Continuing this item has two parts, A and B. If the zeros are real, if the zeros, then you find the zero, if they are real, they are just x-intercepts. Okay, so if they say find x-intercept with the function equal to 0, solve for x. If you get real numbers for the solutions, those solutions are the x-intercept. In this case, the real zeros are either distinct, means there are two of them, different, or the same. And the picture says something like this. They are either like this, separate, or this way, or they're the same. They're one. If they are both equal, would be right here. Would be just a vertex, actually. If they are separate or they are distinct, then they are different points on x-axis. If they are the same, then the parabola is tangent to x-axis at that point. So if they are the same, it would be the vertex and it touches. That's what we mean by tangent to mean touch. If you haven't had that thing, you see if I have a line like this and the curve just barely touches like that, you say you have a tangent, just touching at one point. Okay. So if the zeros are complex, then they will not show on the graph. So that means the graph does not hit x-axis, no x-intercept. In this case, the graph would look like one of these. You see, the graph completely misses x-axis. It has zeros, but zeros are complex and they don't show on real lines. They show on complex lines, not on real lines. But we are not dealing with complex numbers in this case, so we don't worry about complex zeros. Now the next example, I'm going to show you how we can do all these 8 items that we spelled out for quadratic function, and then after we write them all out, then we use them to actually sketch the graph of the quadratic function. Okay. So unfortunately I did this video, but when I looked at it, it didn't have any sound, so I had to do it again. So I already have written everything here, but I'm going to rewrite it for you. Okay. So here's your function, quadratic function, and the first thing I do, I write what my A, B, C are. You see, so here we go. A is -1, B is 4, and C is -3. So these are A, B, C. Then, of course, I wrote the function itself so I can see it easily. Then the first item is that the domain is the whole real line. I mean, the domain is always the whole real line for any quadratic function. So no argument here. The graph is a vertical parabola. Yeah, we know it's always a vertical parabola for any quadratic function. And then I want to know whether this parabola opens up or down. If you look at the A value, we see A is -1, so A is -1 and is less than 0. So that means the parabola opens down. Okay. Then we're gonna find the coordinate of the vertex. Coordinate of the vertex. This is the formula. H is equal to -b/2a. And I have my A, B, C, so I've replaced A with B by 4 and A by -1, and that's what I did. 4 for B, 2 times negative 1 for A. Then because I have two negatives, these two negatives kill each other, you get positive, so you get 4 over 2, and if you divide, you get 2. So H is equal to 2. The X coordinate of the vertex is 2. To find the Y coordinate, see, I use the formula of K equal to C minus B squared over 4A. C minus B squared over 4A. C is negative 3, then minus B is 4 squared, then 4 times A is negative 1. And then this is a very elementary computation. You can do it with or without a calculator. And if you simplify this, you get negative 3, this minus, and this minus gives you plus 16. 4 squared is 16 over 4, which is 4. Negative 3 plus 4 is 1. So K value is 1. Okay. So the vertex is 2, 1. Actually, I can put it right here. 2, 1. Where is 2, 1? This is 2, and 1, 2, 3, 4. So this 1 is right here. You see, this is 1, and this is 2. So 2, 1 is right here. So this is the vertex of your parabola. I already plotted that vertex. Okay. Now we go ahead to the axis of symmetry. Axis of symmetry is always x equal to h. I know what h is 2, so I draw a line, vertical line at x equal to 2. That would be the axis of symmetry. So I'm going to do it with a red. It's red, see. Axis of symmetry. So that means that when I graph my parabola, everything on the right side of this line is exactly like everything on the left side. Symmetry. Okay. So this is the line x equal to 2. Then the range. The range, as I said here, you see, if the parabola opens down like this, the range would be from minus infinity to k, because just everything below vertex are acceptable. Okay? All the y value below the vertex, so we go from minus. If it opens up, everything above the vertex. Okay, so in this case, because it opens down, everything below the vertex, the y of the vertex, so the range is, because the k is 1, so minus infinity to 1 is the domain. So in fact, if you want to do it on see, this is 1 right here. See, what the range is, this is the range. This is the range. Minus infinity. See? This is the range. This red part. This part is not the range. Then, we want to find x-intercepts, as we talked about it minute ago. You have to put f of x equal to 0 and solve for x. Okay, so I put f of x equal to 0. This is it. You see, f of x equal to 0 minus x plus 4x minus 3 equal to 0. I have the choice. I'm going to solve this equation now. You see, I have the choice of doing it either by factorization or quadratic formula. Those of you who know how to factor, let me just show it on a separate piece of paper how to factor it. You see, in this case it is factorable. You see, I have minus x squared plus 4x minus 3. I want this x squared to be positive, so I multiply each one of them by a negative. So this is not positive. Positive x squared, negative 4x plus 3. Okay. Then I have to look for two numbers. They add up to negative 4. The product is 3. Those of you who remember from intermediate algebra. So you put an x here and an x there, and then I have negative 3 and negative 4. If you add up these two numbers, you get negative 4. If you multiply negative 3 and negative 1, you get 3. Then if I put this parenthesis equal to 0, I get 3. If I put this parenthesis equal to 0, I get 1. So these are the x-intercepts, 3 and 1. If you don't know how to factor, or you forgot, just put them in the quadratic formula, and this is a quadratic formula. Minus b plus or minus square root of b squared minus 4ac divided by 2a, and that's exactly what I've done here. You see, minus b is, move it down a little bit here, b is 4, so minus 4, plus or minus b squared is 4 squared, minus 4 times a is negative 1, times c is negative 3 divided by 2 times minus 4. The rest of this is simplification, so negative 4 plus or minus 4 squared is 16, negative times negative is negative, 4 times 3 is 12, divided by 2 times negative 1 is negative 2, then you simplify, 16 minus 12 is 4, then the square root of 4 is 2, so I have this. Then I have to consider plus and minus separately. If I choose plus, I have negative 4. Plus 2 is negative 2. Negative 2 over 2 gives me 1. Okay, like here I have 1. See? Then if you choose negative, you get negative 4. Negative 2, you get negative 6. Negative 6 over negative 2, you get 3. Just like here. Okay. So I got the same x-intercept. You judge for yourself which technique is simpler and you understand it better. So I have the x-intercept. So all I do, I put these on x-axis. So 1 is right here. You see, this is 1. And 3 is right here. This is 1. And this is 3. So x-intercept is 1, x-intercept is 3, vertex is 2, 1, and y-intercept, I think, yeah, here we go. Y-intercept, I found it, I didn't talk about it. Y-intercept is f of 0, and if you put x equal to 0, you get negative 3. That's why negative 3, which is right here, let's see, 1, 2, negative 3 is right here. So this is the y-intercept. So you, let me get my pencil. So you know the shape of the graph. You see, that's the thing. Your shape of the graph is a parabola and it opens down. So you gotta get something like this. So you know that you're gonna get something like that, right? And you know that this point right here is right here. So you have something that comes down like this, like a V-shaped kind. U-shape down, and then goes through this point, and this point. So all you have to do is draw a nice parabola thing through these. Okay. And then it's symmetric. Then I just copy this on the other side and goes through this point. You see? Make sure it's as symmetric as you can. Then, since I have it with pencil, then I go ahead with my pen. See? This function. Very nice and very enjoyable to do it. I don't know if you enjoy it, but when I was learning this thing many, many years ago, I'm old enough to say many years ago, I enjoyed it. Actually, my brother-in-law, my sister's husband, was my math teacher. He was pretty good, and he helped me a lot to understand all these things. It wasn't easy, but I managed to understand. So let's do the next example. Okay, here's the next example. Actually, this is example 3, right? Just did example 2. And I did example 3 a minute ago, but unfortunately, video didn't have, I don't know why this program is giving me so much trouble. Sometimes I record the video but doesn't have sound. Like happened, I just did the video for this, really, you see, but didn't have sound, so I don't have a blank copy to redo it. So what I'm going to do, I'm going to go through it carefully, show you what I've done. Okay, so we're going to repeat this example, do those 8 items for this function. So let's see what we have. First of all, the first thing I did is to write the value of A, B, C. A is 2, B is 3, C is negative. Okay, A. Then the next thing I did, of course, I don't want you to see the graph either, so let me put another piece of paper on the graph for now. Thank you. I'll get to it later. Then the domain is just don't look at the graph for now. The domain is minus infinity to infinity. That's true for all the for all quadratic functions. And then the graph is a vertical parabola. And your A here, you see A is bigger than 2, so it opens up. Here's the graph that I did. So, but I don't have it as I said, I recorded this video, didn't have sound, so I have to redo and use the same thing I did again. Okay. Then I find H, the x coordinate of the vertex. H is minus b over 2a. Minus b is 3 over 2 times a is 2, so you get negative 3 over 4. Negative 3 over 4 is right here, you see. Okay, this is negative 3 over 4, which is about negative 0.75. And k, the y of the vertex is c minus 4, c minus b squared over 4a. C is negative 2. See, maybe I have to turn off this light so you can see better. C is negative 2, so I put it right there. Minus b squared, b is 3, so you get 3 squared over 4a. A is 2, so you get 4a. So you get negative 2 over, negative 2 minus 9 over 8, and you have a minus. So you have negative 2 minus 9 over 8, you get negative 25 over 8. And I did this on my calculator. If you are a person who's using calculator, this is how you do it. You see, do it one more time here. If you want to do this, you say negative 2, let me make it bigger so you can see it actually. As well. Negative 2 minus 9 parentheses 9 divided by 8. I get that number, and if I change it to, if I want to change it to a fraction, I go to math, see, math, and then I use number 1. Number 1 means fraction. Then I say enter, then I get negative 25 over 8. And that's what I have. K is negative 5 over 28. Okay. And now I have both H and K. H is this, and K is negative 25 over 8 right here. You see, this is negative 25 over 8. It's about negative 3.125. So this point becomes a vertex. Ignore the graph for now. Suppose you don't have the graph. Okay. So you have the vertex. So I got the vertex. Then axis of symmetry is a vertical line through the vertex. So this is your axis of symmetry. So this is x equal to minus 3/4 is the axis of symmetry. Okay. And range because the parabola opens up, the range would be from the y of the vertex to infinity, which is from y of the vertex, which is negative 25 over a, to infinity. So this red segment is the range of the function. Then y-intercept is g of 0. G of 0 means in g, replace all these x's by 0, and I did. I got negative 2. So y-intercept is negative 2, which is right here. Negative 2, y-intercept. See, y-intercept is negative. And now the last thing we do for this problem is to find the x-intercept. To find the x-intercept, you put g of x equal to 0. And I put g of x. G of x is negative 2x squared plus 3x minus 2 equal to 0. I put that equal to 0, and I know my ABC. A is 2, B is 3, and C is negative 2. I put those in my quadratic formula. You see, minus 3 for B, minus B, plus or minus B, which is 3 squared, minus 4 times A, which is 2, times C, which is negative 2, divided by 2 times A, which is 2. Okay. Then I carry out these simple calculations here. Negative 3 plus or minus, this is 9. This is 16. So 9 plus 16 divided by 4. 9 plus 16 is 25. So negative 3 plus or minus square root of 25 over 4. Square root of 25 is 5. So negative 3 plus or minus 5 over 4. Then if I choose, let's say plus, if I choose plus, negative 3 plus 5, you get 2 over 4, which is 1/2. And then if I use minus, negative 3 and negative 5 is negative 8. Negative 8 over 4 is negative 2. So these are your x-intercept. And then I put those on x-axis. 1/2, one x-intercept, and negative 2, another x-intercept. Then the first thing I did is the graph has a minimum point at this point, vertex, and opens up, go through this point. So this is the graph I get for it. Nice. And one last thing I wrote down was to say that this function, because it opens up, has a minimum, local minimum. So g of x has a minimum value of negative 25 over 5 over a at x equal to negative 34. See the vertex. So that's what we have. So okay, and these are the two functions I just did the example. This is example 2, this is example 3, and as you can see, I'll just show you. For example 2, the vertex was 2, 1. Just like I wrote here, it has a maximum value of 1 at x equal to 2. Then I write it here, f of x has a maximum value of 1 at x equal to 2. For the second one, you see, g has a minimum value of negative 25 over 8 at x equal to negative 34. That's what I wrote. So this is really nothing new, I just mentioned it. The next topic we're going to talk about is another a new presentation of quadratic function. As I said, this presentation, or this formula here, is called general form, ax squared plus bx plus c. But this theorem says that I can rewrite this form in this shape, this form. The same a times a parenthesis, then inside the parenthesis x minus h to power 2 plus k, and this h and k are the coordinates of the vertex, which is pretty nice actually. You see, you don't see vertex in this form, but you see it right here. So if I write my equation in my formula or my function in this form, then I can tell what the vertex is, the coordinate of the vertex are. Okay. This is called the standard form or vertex form. So what we're going to do, we're going to learn in this page and these examples how to go from standard form to vertex form to general form, and conversely how to go from general form to standard. So sometimes they give it to you this way, they say write it this way. Sometimes they give it in this form, they say write it in this form. Okay, so this is what it says. The quadratic function given in general form, this can be written in the standard form this way, where hk are the coordinates of the vertex given by the formula. We just property number 4. We can always find h and k by that formula. Okay. Conversely, a quadratic function given by a standard form can always be put in that form. Okay. In this remark, I said that we are not going to prove this theorem. Okay, there is no point of proving this theorem. So the only thing we're going to do is to actually see how we can do this kind of transformation. How do I go from this form to this form, and how do I go from this form to this form? Okay, so that's what we're going to learn. The proof of the theorem really, we really don't need it. That's the bottom line. Okay, so now here is the first type. The first thing we're going to do is to go from standard form to general form. So that's what this example is. The following quadratic functions are, there are two of them, right? This is A and B. The following quadratic functions given in the standard form. You see, they're given in the standard form, and we want to find for each one, we want to find first the coordinate of the vertex, and then convert it into general form. Okay, so that's what we're going to do. Two things. By looking at it, we want to know what the vertex is, and then we're going to write it in the general form that way. Okay, so if I compare this one with f of x equal to a times x minus h squared plus k, if I compare these two, then clearly your a is 3, and this x corresponds to this x, this minus corresponds to this minus, therefore 5 corresponds to h, so h is 5. And then plus corresponds to plus, and 1 corresponds to k, so k is equal to 1. So here we go, this is your vertex. I even have to use the formula for it, because it's right there, I can get it from the shape. Then I'm going to convert it to general form. So what I would do, I just write f of x equal to 3 times x minus 5 squared plus 1 equal 3 times x minus 5, quantity square means x minus 5 times x minus 5 twice plus 1. So what you do then you foil this. Actually I did this some time ago. Multiply these, you see, and then multiply these two. So let's see what we get. 3 times x is x squared, x times 5 is minus 5x, then 5 times x is another 5x, and then minus 5 times minus 5 is plus 25, plus 1. And if I continue this, I have 3 times x squared minus 5 and minus 5, we get minus 10x, plus 25 plus 1. And then if I multiply this 3, I get 3x squared minus 30x. 3 times 25 is 75, then plus 1. Finally, squared minus 30x plus 76, and I'm done. See, you started with the standard form and you ended up with general form. Pretty simple. Let's do another one. Again, a is negative 2, h, if I write the formula under it, g of x equal to a times x minus h squared plus k. See? So a corresponds with negative 2, x corresponds to x, and then you have plus here, minus there. So I can rewrite this as minus minus 3. So if these two signs are opposite, that means h is negative of that number. So h is negative 3. And the same thing here. If these two signs are opposite, that means k equal to negative 7. Okay, so these are the now if I continue to write it in general form, so I say g of x equal to negative 2 times x plus 3 quantity squared minus 7 is negative 2 times x plus 3 times x plus 3 minus 7. Again, if you FOIL, you get negative 2 times x is x squared plus 3x plus another 3x plus 9 minus 7. And if you multiply, you have negative 2 times x squared minus 6x plus 9 minus 7. Multiply this negative 2, you get negative 2x squared plus 12x minus 18 minus 7, and finally is minus 2x squared plus 12x minus 25, and that's it. So general, this is a general form. Standard form, general. Then the next two problems, next two examples are the opposite. You are given the general form, you want to find it in the standard form. So you need h and k. So in this case, a is negative 1, b is 4, and c is 3. So what you do, you go ahead, use formula for h and k, and put them in the formula again. So h is minus b over 2a, and this is equal to minus b is 4 over 2 times minus 1, so you get 2. K is c minus b squared over 4a, c is 3 minus b 4 squared over 4a, negative 1 for a, so you get 3, then minus and minus, we get plus, you get 16 over 4, you get plus 4, so you get 7. 3 plus 7. So then, so h is equal to 2, k equal to 7, and then I have f of x equal to a times x minus h squared plus k. This is the formula, so I can replace a is negative 1 times x minus h is 2 squared plus k is 7. And that's the final product. The next one is similar. A is 2, B is negative 8, C is 3. So I find H first. H is minus B over 2A. B is negative 8 over 2 times 2. So you get 8 over 4, you get 2. That's accidental, you got the same number. H. K is C minus B squared over 4A. C is 3. I guess I have a tiny error. I apologize for that. First one, C is minus 3. Sorry about that. C is minus. So let me just go ahead and do the correction. C is minus 3, so I have a minus 3 there. So I get I'm sorry, I apologize. It's negative 3 plus 4 instead of 7, you get 1. So this is 1 here again. Them in this formula, I get minus 1 x minus 2 squared plus 1. Okay, so I was careless a little bit, so please be careful. Here now is my h is okay. C minus b squared over this. C is 3 in this case. C minus b is negative 8 squared over 4a, which is 2. So you get 3 minus, because this minus squares becomes plus, you get 64 over 8. Okay, so it's 3 minus 64 over 8 is 8, so you get minus 5. So h is 2, k is minus 5. Put it in the formula. F of x equal to a times x minus h squared plus k. So f of x is equal to a, the a is 2. Right here, so 2 times x minus h, x minus 2 for h squared plus k, but k is negative 5. Okay. There is one more type of function here that we learn is the type where they give you certain information about your function, the quadratic function, and they want you to find the equation of that. Okay. Usually these two information, one of them is the vertex, and then another one is another point or some other point other than vertex. For example, here he says find the standard form of a quadratic function when the vertex, this is the vertex, and it also goes through this point. So how do I do this kind of problem? Okay, so that's what I'm going to show you. Well, we just did this example. I was about to do this example right here. Again, as I said, I recorded the video but didn't have sound. This is really driving me crazy. I have to do things twice sometimes. You see, I did this example, and I watched the video, didn't have sound. So what's the use? So I'm going to do it again. Hopefully it will have sound. And I don't have a blank copy, so I already have things written here. So what I'm going to do, I'm going to just explain what I did. Okay. So here's the idea. First of all, is that the question is asking you to find equation of a quadratic function that has a given vertex and goes through a given point. Okay, that's the idea. So the vertex is given, and one other point is given. That means that the graph goes through this point. That means if x is equal to 4, the y value would be 1. So usually to do these problems, you always start with this formula right here, the standard formula. Y equal to f of x equal to a times x minus h squared plus k. Okay, and that's a standard formula. Remember, standard equation. Then I need to have a, I need to have h, I need to have k. Well, I have h and k. See, the vertex is given to me by the problem. Since the vertex is that, so vertex is 3 and negative 2. So h is 3, k is negative 2. So all that first thing you do, you replace this h and k by these two numbers. So h is 3, k is 2. Okay. So this formula, the green one, becomes this guy here, y equal to a times x minus 3 minus 2. Am I done? No, because we have to find a. To find this a, I use this extra information given to me. That 1 is on the graph. You see, point 4 and 1 is on the parabola. That means in here, if I replace y by 1 and x by 4, then I can solve it for a. And that's exactly what I did. In this equation right here, I replace this y by 1 and this x by 4. So this thing becomes this. Simplify it. 1 equal to 4 minus 3 is 1. 1 squared is 1. 1 times a is a minus 2. Then the unknown is a. I add 2 to both sides. I get a equal to 3. And therefore y equal to f of x. I replace this a by what I got, 3 times x minus 3 squared minus 2, and that is the equation of a parabola I was looking for. Okay. The next example, again, that was a part of the video that I recorded and didn't have sound. Second example. It says use this graph here. You see this graph right here. Find an equation for it. It's a quadratic function. I have to find a quadratic formula, quadratic equation for it. So again, I need a vertex. I need the vertex, and I need another point. See, they are not given to me in the context of the problem, but I can get them from the picture. And unfortunately, the grid points, it's very hard to see the grid points. Maybe I should have been careful with that, and maybe should have made the picture a little bit bigger so you could see it. But it's not too difficult to see. You see, the vertex is, this point is 2, negative 2. This is 3 right here. So this vertex is negative 2, 3. See, vertex is negative. I have to find another point. So look for easy point. Look for those grid points which are at nice numbers. For example, if you look at this point right here, which happens to be the y-intercept, is 0, minus 1. So the graph goes through point 0, minus 1 and happen to be the y-intercept. So don't you think that I have to have the y-intercept. No. It's convenient to use the y-intercept because this x is 0. I could use some other point like this one. So this point is negative 3, 2. I could have used that one. Or I could have used this point here, negative 1, 2. But doesn't matter which one of these 3 points you use, the final answer will be the same. So here are my given information. You see? And then I do the problem like the previous one I just did a minute ago. I start with y equal to f of x equal to a times maybe make this one nice clean. I'm kind of picky sometimes. There we go. X minus h squared plus k. Then I replace this h and this k by these two numbers. So a times x minus, then h is minus 2 square plus k. K is 3. Maybe I should have put 3 for k. Here is this. See, k is 3. Then if I simplify, I get y equal to a times x plus 2 squared plus 3. And what is a? To find a, I use this y-intercept given to me. So I replace here, I replace this y by negative 1 times a equal to a times x. X is 0 plus 2 squared plus 3. And if I solve this equation, I get a equal to minus 1. And then I replace this a equal to minus 1 to get my last answer. Okay? So that's right. Okay, I'm gonna do this one more time because I just did the video of this example. It will have sound again. So let's try it again. We have a golf ball. Here we go. Just makes this one xy axis, let's say here. So x-axis is the ground, and the golf ball is here, and then it's hit, goes up to the maximum point, and then falls down. Then in physics, we can show that this path is nothing but a parabola. In fact, we call these projectile motion. Path is called trajectory. So this is the initial spot. This is where it falls. The two questions here is asked is what is this maximum height? This is maximum height equal to what? Because it's a parabola, maximum height is k. K is c minus b squared over 4a. Okay. And then the second question is how far from the initial spot the ball falls. You want to find this distance between these two. That's what you want to find. So you have to find, we need to find this x-intercept. We have to find this one. Okay. I can find this one by formula, but these two, if I use the formula, becomes a little bit nasty because my numbers are really nasty looking numbers. So I'm going to find these x-intercepts by a graphic calculator, like my graphic calculator. So the first part is that maximum height is equal to k equal to c minus b squared over 4a. And this is equal to, and if you look here, you see your a is 0.016, b is 4, and c is 140. See, I have written here, it's kind of a lot of mess. Just one little on this paper. So if I put this A, B, C in this formula here, C is minus 140 minus b is 4 squared over 4 minus 0.0116. And if I put this in my calculator, I get 110. Let's say the unit is in feet. So this maximum height is 110 feet. Okay. Then I want to find x-intercepts. I want to find these 2 points. I use my graphing calculator. See, I go to y. I have typed it already because, as I said, I did it once, but didn't have sound. So I'm going to find x-intercept is the graph. So I go to second trace. I use number 2. Let's find this one first. Put it on the left side, enter. Put it on the right side, enter, enter. You get about 208. So this point here is 208. Then to get the other one, say second trace, number 2 again. With this point, this cursor on the left side. Put it on the right side, enter and enter. I get about 42. So this point is about 42. So part 2 is 208 minus 42. How much is that? It's 166. So it's 100. The ball will fall 166 feet. From the initial spot. Okay, that's the solution. And your paper, you see, this is what I had. This is the graph, and the maximum height. K is the maximum height. 110 feet, maximum height. And then I found this point to be 42. This one 208. It's subtracted 166 feet. Okay. Let's do this one more example. I will not do this last one. See, I'm not going to do this one. I spelled my T. Let's do this one. Well, it says we have 100 feet of fencing. So we have a fixed amount of fencing. I can put it around the rectangular pen for my dog. So, of course, when you do that, maybe your fencing is like this, maybe it's like that. See, maybe it's like this. The area may change, but you use the same amount of fencing. So the idea is, how can I use this 1,500 feet of fencing for a fencing with maximum area? See, I can do it like this, very narrow, use the same amount of fencing for each one of these, but I mean, I don't like it to be like that. I mean, my dog doesn't have room to move around. So you want to do it in such a way that the pen that you create has maximum area. Okay. So every time you have a problem with maximum, minimum, you have to use quadratic function. Okay. So you want to know what the dimension of the pen gonna be. Okay. So I call the width x, and I call the length y. Okay. Then of course this side gonna be x, this side gonna be y as well. Then the perimeter should be equal to 1500. That's what you're going to do. Perimeter is exactly the amount of fencing you use. So perimeter is this side plus this plus this plus this is going to be 2x plus 2y. So 2x plus 2y. So this is part 1. 2x plus 2y is equal to 1500. Okay, and then the area, A is the area, is equal to x times y, length times the width. Okay, but I don't need to have both x and y there. I gotta get rid of one of them. I use the stress equation to do that. So this equation here becomes x plus y equal to 750 if I divide by 2, you see. And then this one, I can get y equal to 750 minus x. And then what I would do, I replace this y here by this. So I get A area equal to x times 750 minus x. And this is the equation that represents the area. See, this is part 1. Then you have a choice to, I'm going to continue on this paper here for part 2. Okay. Then what you do, you can do it either by graphing calculator or non-graphing calculator. I do non-graphing I prefer non-graphing calculator. So I multiply this. I get x times x, negative x squared plus 750x. That's the same thing. You see, if I multiply x times 750, you get 750x. X times negative x, you get negative x squared. So in this case, this is a quadratic function. A is negative 1, B is 750, and C is 0. Okay. So you want the maximum area. So the maximum area is because now A is your y value. You see, so vertex. So maximum area is K at x equal to h. So if you choose your x to be h, then the area, maximum area, A maximum is 8. So A max equal to K at dimension x equal to h. Okay. So x equal to h equal to minus b over 2a. B is 750 over 2 times minus 1, and if you divide 750 by divided by 2, you get 375. So if I choose this side to be 375, see, then what is y gonna be? You see, y gonna be 750. This is the width. Then the length is y equal to 750 minus x. So it's gonna be 750 minus 375. You get 375. So this one would be 375 as well. So that means in order for this pen to have maximum area, it has to be a square. Okay, that's it. So this area is maximized. So what we have is this. The picture is like this again, right? yeah, 375, 375, 375, 375. So this area is maximum. I don't care how much is the maximum area is, I just know it is maximum. So that's how I'm gonna build my pen for the dog. Okay? So let's go over it one more time. You have 1,500 feet of fencing. You wanna enclose a rectangular area by that 1,500 feet of fencing. You wanna know what the dimension of your rectangular pen should be in order to have maximum area for your dog. Then you call this one x, this one y, so this is x and y, so 2x plus 2y is 1,500, because the perimeter should be covered by this fencing. And then if you divide everything by 2, you get that. And then the area is length times the width. And then what I do, I gotta get rid of y, so I use this formula here, x plus y to 750. I subtract x from both sides, so I get y equals 750 minus x. Then I replace this y by all of that in terms of x. And if I do that, then the area, this is the formula for the area. So this is part A. Part I. And then for part B, it says find the dimension of the area that maximizes the dimension of the pen that has the maximum area. So I want to find what x and y should be for this area to be maximum. Okay. So this is the equation of the area. So I want to choose this x that maximizes the area, and that happens with the vertex, because after all, this is a quadratic function. A is 1, B is 750, C is 0. So A max is the k of the vertex. The dimension x is the h of the vertex. Okay. And x, which is h, width, is equal to minus b over 2a. And I put these numbers a, b, c in it. I get 375. And then I put this 375 here, this formula, to get the dimension y. That happens to be also 375. So that means the shape of the pen should be a square. So 4 sides and all 4 sides 375. If you add them up, you get 1,500, of course. Okay, but the area is maximum. So this concludes this section.